Good evening, I'm Ashutosh. This is a demonstration video of my project abapLLM. So let me define the problem statement first. So ABAP developers in general often produce inconsistent code due to various levels of expertise and understanding of best practices. Hence, a helpful assistant that assists developers throughout their development journey is what they need. So this solution could give optimized code and display best practices. And code reviewing in general is a very time consuming task. Hence, an LLM powered assistant that reviews code in a matter of seconds is something that can enhance the productivity of developers. The solution I've come up with is an LLM integrated chatbot. The LLM I've used here is Meta's 80 billion parameter model. It has been given external knowledge source of web processes and best practices. I've also developed a few grading systems for better contextual and reliable responses. Let me walk you through the code. Hey, welcome to the code walkthrough. The code of this project is available in my GitHub. So let me walk you through the code. First, let's understand the architecture of this project. So since it's a chatbot, after the user enters his query, the LLM searches the vector store for relevant information. If it finds any relevant information, these documents are then sent to a grader which checks for which filters these documents on the most relevant ones. So after fetching the most relevant documents from the vector store, these documents are then sent to the RAG pipeline to perform a RAG, or classical vanilla RAG, which generates the response. So if there is no relevant information in the vector store, the LLM resorts to searching for the web, for the searches the query in the web to find relevant information. These documents are then filtered again by the grader, and then the filter docs are sent to the RAG pipeline where the response is generated. So before this response is displayed in the front end, it goes through two other graders. One grader is the hallucination grader, which checks if the LLM is hallucinating or not. We do not want any hallucinations here. So after the hallucination grader checks for hallucination, the response is again graded on its relevance to the query given by the user. So after both the graders, after the response passes both these tests, it's then displayed in the front end where the process ends, and then the LLM is ready to take another query. This fallback node here, the LLM moves to the fallback node whenever the user enters a query which is not related to SAP or ABAP, and then the process ends here. The LLM says that it's not allowed to take queries that are not related to ABAP and SAP, hence the process ends here, and another response is taken by the chatbot. So that's the architecture of the project. Let's see the code here. So in the vector db.py, we've loaded all the URLs in here, the data urls.py. These URLs are available in the SAP's official documentation on ABAP. So these URLs contain information regarding these topics. It has information on CDS, EML, objects, SQL, exceptions, our AP, and all those things. So these URLs are loaded in the vector db, and then they are chunked with a chunk size of 1000, and then an overlap of 100 characters. So after they are chunked, this Hugging Face embeddings are made out of them, and then this information is stored in the vector store. So and then we have config.py, which where we set up all the API keys, that is the Grok API key and the Tabula API key, which does the web search here, and then the LangChain API key. We have LLM config.py, where we load the Llama 370 billion parameter model with a temperature of 0.75. We've used Grok API key here. Then we have LLM utils.py, which contains three chains, namely the quotient router chain and fallback chain, and then a RAG chain, and their corresponding prompt templates here. So these chains are then used in other parts of the project. And then we have models.py, which has two pedantic base models. One is the vector store, which contains information on these topics, and then we have the search engine, which takes queries related to ABAP which are not stored in the vector store. These classes are then used in other parts of the project. Let's see the graders.py. The graders.py contains three graders, namely the grader here checks and filters the documents fetched on their relevance, and then these documents are filtered based on their relevance. And yeah, we have the grader hallucination grader, which checks whether the LLM is hallucinating or not. It says yes if the LLM is hallucinating, and no if it is not. Then we have the answer grader, which checks whether the given response, given by the LLM is, actually answers the query given by the user. So it says yes if the answer response generated answers the query given by the user, and no if it is not. And then we have agents.py, which contains nodes, all the nodes here. We create two tools here that the LLM uses. One is the vector store to search, to call the retriever and invoke it, and then we have the search engine, which searches the web, which enables the user to search the web. And then we have all these nodes. We have the retrieve node, which retrieves information from the RAG, from the vector store. We have the fallback node, which takes all the chat history and then generates a response by taking the query and the chat history. And then we have the filter documents node, which filters all the relevant documents fetched from either the vector store or the web. And then we have the RAG node, which invokes the RAG chain. And then we have the web search node, which performs web search, of course. And then we have the question router node, which routes the LLM to either fallback or vector store or web search. So it returns vector store if there is relevant information in the vector store according to the query given by the user. It returns search engine if there are no relevant information if there is no relevant information in the vector store, and generates and returns LLM fallback if the query is not related to ABAP at all. So this should generate function here we have this should generate function which returns generate if there are any filter documents that are returned, and if there are no filter documents it returns the word search engine, a string here. Yeah. So and then we have the hallucination and answer relevance grader, which checks whether the LLM is hallucinating or not. If the LLM is not hallucinating, it checks for the relevance of the answer to the query and returns useful if the answer is relevant, and not useful if it is not relevant. And then it returns the word generate if the LLM is hallucinating. So after agents.py, we use all these nodes in graph.py, where we create nodes out of them, and their corresponding functionalities are here after the comma. We use LangGraph to connect all the nodes here. So at the beginning we have set conditional entry point, where the question router node returns either LLM fallback or vector store or the search engine. And then we create edges between all the nodes here. So after the LLM searches and finds relevant information from the vector store, these documents are then filtered. So that is why we have an edge between the vector store and filter docs node. We also have an edge between search engine and filter documents, because the documents fetched from the web are then filtered too, right, by the grader. And then we have add a conditional edge. So whatever this function generates, if it generates search engine, an edge is created between filter documents and search engine. So if it returns the word generate, an edge is created between filter documents and RAG. This does the RAG pipeline. And then we have another conditional edge, where if this function generates, returns useful, the string useful, the process is ended from an edge is created between RAG and end. That is, the process ends after doing RAG. And then not useful if it returns not useful. The LLM does web search again. If it returns generate, the string generate, it does the RAG again, so as to generate another response. So this is the graph.py, where we've connected all the nodes, and we also have app.py, which enables the user to interact with the chatbot and seek relevant answers. So that's the code walkthrough. Let's see the demonstration. Hey, welcome to the demonstration part. So here we have our app running on localhost 8501. So our abapLLM says, "Hello, I'm a bot. How can I help you?" So let's say hello. It's processing, and then it says the response is ready. "Hello, I'm an SAP assistant specialized in ABAP development. I'm here to help you with any ABAP related queries you may have. What's on your mind? Do you have any specific topic or question or topic you'd like to discuss?" Let's ask, what is ABAP? So it's processing, and then it says ABAP, Advanced Business Application Programming, is a high-level programming language created by SAP CSE, a German software company. It is primarily used for developing business applications and so on and so forth. Already generated a sample example of ABAP code. So we've asked information related to ABAP, right? Now let's ask a query, which is this query, and ask on topic which is not related to ABAP at all. So let's ask, who is the Prime Minister of India right now? So when it comes to a query which is not at all related to SAP or ABAP, the bot responds with, "I'm happy to help you with ABAP-related queries, but I'm afraid I'm not equipped with I'm not equipped to provide information on current events on or politics. My expertise lies solely in SAP and ABAP development. If you have any questions or topics related to ABAP, I'm more than happy to assist you." So let's say, okay, explain what are ABAP CDS. It's processing. There we go. We have the response. ABAP CDS stands for ABAP Core Data Services. It is a part of ABAP programming language that allows developers to define and consume data models in a declarative way. And it has some other content. It has generated an example of ABAP CDS entity definition. So here it is. And then we have ABAP CDS provides many benefits, including and all the data. Now let's query the bot and provide code from the official SAP ABAP documentation. Provide this code right here on CDS source code here, and then let's say explain the code here, explain the code, and display the best practices. So I've provided the code source code in this URL here. We've also included this URL in the data url.py. I haven't included all the other URLs. I've commented them out because for loading all these URLs, it takes a lot of time. Load all these URLs into the ChromaDB. So for the demonstration purposes, I've only loaded a single URL. So it's processing. It says please wait. Have a response. The response is ready. So after giving the code from the SAP's ABAP documentation, it says let's break down the code and provide explanations and best practices. Class definition, it has done all that. Class implementation. This is the implementation of the main method. It's given all the steps and all. Then it is also provided the best practices of followed in the source code, and it's also given an optimized version of this code here. In the optimized code, I have replaced hard-coded values with constants, renamed the method to consume business services, broken down the code into smaller and more readable sections, used more descriptive variable names, removed unnecessary code. So it has optimized the source code I've given into something better, right? So that's the demonstration of the project. So yeah, I have provided external knowledge base, custom knowledge base to an LLM, and it takes queries which are only related to ABAP and only answers queries related to them. It optimizes the code given by the user, explains topics which are related to ABAP, and yeah, that's the demonstration part. Thank you for your time.